I'm talking on absorbance and transmission and reflectance of cadmium thin film deposited by SILAR method for photovoltaic application. This experiment was carried out in Nigeria here at the Nigeria University, Nsukka. And then the cadmium oxide recently has revealed himself as a transparent material. That is why the choice of cadmium oxide was used here, better than zinc oxide. And then cadmium oxide, there are various experimental methods used in depositing that. We tried CBD, but CBD was not giving us a good deposition. We tried spray pyrolysis. It wasn't giving us a good deposition. That is why the choice of SILAR method was used to deposit the thin film. 7.72 of the cadmium acetate was dissolved. You can see it in the screen here in the still water. And again, the same thing was done. You can see the precursor of sodium hydroxide was used also. And then it's only 4 grams of sodium hydroxide was dissolved in the distilled water, and 20 centimeter cube of analytic ammonia was equally dissolved in 80 centimeter cube of distilled water. And then we use about 4 beakers for this experiment. One where we have the cadmium acetate, dissolved cadmium acetate, and the second beaker, there was distilled water there. The third beaker, sodium hydroxide, was used, and the last beaker was distilled water. The glass substrate was deep in for the first cycle, because we have about 25 cycle, 30 cycle, 35 cycle, 45 cycle. For this, for the first cycle, the substrate was dipped in acetate, in cadmium acetate for 10 seconds, and rinsed in water, in distilled water, that is the second beaker, for 5 seconds, and immediately transferred to sodium hydroxide solution for another 10 seconds, and rinse for 5 seconds. That constitutes a cycle. A cycle is made up of 30 seconds, 10 seconds in acetate, 5 seconds in distilled water, 10 seconds in sodium, and 25 at the first cycle. At the first 5 cycles, there was no noticeable deposition on the substrate, and until about 25 cycles, where we have a noticeable deposition. And then it ran from 25 to 30, and then 35 to 40 cycles. At 45 cycles, we noticed a very deep deposition of cadmium acetate. That is the reason why the experiment was limited to 25, 30, 35, and 40 cycles. The same thing was carried out using ammonia as a precursor. Then look at the graph of absorbance against wavelength for sodium hydroxide as a complexing agent. Look at the graph. You can see the absorbance there decreases with increase in wavelength, even at 25, but we can see the absorbance was higher at 25 cycles for sodium hydroxide, and then least in 40 cycles. But what we notice generally is the absorbance of the deposited thin film of cadmium oxide decreases with increase in wavelength. Please, can you go for the next slide, please? The next slide. This is for ammonia as a complexing agent. And then we can see the absorbance was higher in a 25 cycle, but then comparing ammonia as a complexing agent and sodium hydroxide as a complexing agent, we can see the absorbance is higher in ammonia for 25 cycle. The previous graph shows a kind of a decrease in 25 cycle. In 25 cycle, the absorbance was higher for ammonia, but then the trend of decrease with wavelength was equally observed in both complexing agents. Sodium hydroxide as a complexing agent and ammonia as a complexing agent. Please go to the next slide so that we can see the transmittant. This is the transmittant graph for sodium hydroxide as a complexing agent. We can see the transmitter is also higher for 25 cycle. Look at that there. But there, the transmitter here increase with increase in wavelength, but higher in 25 cycle and least in 40 cycle, as you can see in the graph. But there is you can notice a kind of overlapping in the graph when at 35 cycle and 45 cycle respectively for the transmittance of deposited cadmium oxide thin film. Can you go to the next slide, please, so that we can see that of the okay. This is the graph of using ammonia as a complexing agent. But what we noticed is that the transmitter was also higher in ammonia as a complexing agent compared to sodium hydroxide as a complexing agent. But in both cases, the graph saw an increase in wavelength as the transmittance increases. But the transmittance was least when at 40 cycle. Please go, let's see the absorbance for the graph. Please. Yeah, the reflectance. Can see the graph of the reflectance over there. This is graph for reflectance when sodium hydroxide was used as a complexing agent. But then what we notice in all the graph, we can see that the reflectance is the transmittance and the absorbance was higher at 25 cycle for both ammonia and as a complexing agent and sodium hydroxide as a complexing agent. In this one, this is ammonia as a complexing agent. We can see the overlapping again at 25 cycle and 40 cycle respectively. Thank you. Let's see the implication of this. The application, go to the next slide, please. The next slide. Okay. The higher reflectance exhibited by this material make it useful in the manufacture of highly reflecting mirror commonly found in desktop. And if you notice, if you read the literature, you can see there are other applications of those two film deposited by ammonia as a complexing agent and then sodium hydroxide as a complexing agent. More work will still come by God's grace. Thank you for listening. God bless you. Thank you for listening. God bless you.